Hi, this is Chris from RoboSprout. I was just going through a list here of the things I'm going to use to modify this Manncorp pick and place to make it work with these Siemens feeders. The first step is you have the Siemens, this is a 3-lane, one of the feeders, the Schultz feeders or whatever you want to call them. They're fairly commonly available online. You can go around eBay or whatever. They're all over the place, but Bill Seff had made a board for OpenPNP, which makes it converts the level shifting, because these use 30 volt, UART transmission communication. So this board here does the level shifting for you, and it hooks it up so that if you were running OpenPNP, you could just plug it in as a device and configure it, and you can run 20 feeders. It's a cool little device and a little board. I thought it was great. It saved me a ton of time, so I actually sent them a Smoothie Board V2 for that thing. But my plan is, since what I need to do is convert a 20 millisecond pulse from the pick and place into a G-code signal, because what this actually does is it converts G-code to the communications protocol that sends the necessary messages to the feeder to convert it to do things like advance or send receive communications. All that stuff is embedded in here, but it runs on G-code, so you can just send it straight G-code. Well, if I have a 20 millisecond pulse and then I need to convert that to G-code, I decided there's an easy way to do that for me, seeing as I work with SmoothieWare. SmoothieWare has in the switch module a configuration where you can send G-code based on if it's if a pin's triggered, you can send G-code. So you could send G-code with a switch. So what I'm going to do is I'm going to use a V2. This is one of the prototypes that through development we've had that are just kind of around. It has some flaws that I'm hacking around because I'm not going to use it all. I just need the digital side of it. And I'm going to connect, this has 63 GPIO, so I'm going to spare GPIO on those headers, so I'm going to connect those headers to this adapter board here, which will take 5 of the headers, 7 each, so I'll have 35 different pins here to be able to work with. And then we'll go over here and connect that to this parallel adapter, which is, or whatever, you know what I mean, but it's going to go connect into here, which is where the feeder bays would connect, and then from there I have to interpret which pin gets triggered and which signal, and then I'll set up a config in the Smoothie, so as this pin here goes low for 20 milliseconds, it's going to send through this board over to the Smoothie board, and the Smoothie board is going to send G-code out of its UART, which I'm going to use into the UART here, into this board, which is going to send the signals over to the feeders to actually drive them for an advance. I don't need all the advanced communication, I just need it to do an advance when triggered. So that's all I'm looking for, because again, Manncorp wanted about over $30,000 to add 30 lanes or 32 lanes of 8mm tape. I'm adding 30 lanes for about $1,500. So aside from having to build my own stuff and wire my own things and go through this process, it's really significantly worth it. So I'm going to document all this as I go, and anybody else with one of these machines, because this is still fairly common on the current stuff, I believe. I'm not sure if they still use these Autotronic feeders in the Manncorp or not, but they want about $800 a piece for them. So for the single lane 8mm, whereas these ones are 3-lane 8mm, and they're about 150 each used online. So you could save yourself a lot of money if you have one of these machines and want to put a little time into it. All right, more to come. Thank you.